So one context in which you might meet surds is when attempting to solve equations. The first step here would normally be to divide both sides by 3, because we want to do inverse operations. To undo a times by 3, we'll divide by 3, and that'll get x on its own. Feel free to do that. It turns out that sometimes it's a good idea to simplify surds first. Just by my experience, I know that here this is one such occasion where it is a good idea to actually do the simplification of this surd before attempting to go on and solve the equation. So I'm going to do nothing with this, just leave the 3x alone for the moment, and simplify this in the normal way. 45 is 9 times 5. It's lots of other things as well, like 15 times 3, but remember I want to make a square number factor, and I'll put the square number first. They can then move into separate houses if they so wish. Okay, and the square root of 9 is just 3, so I've got 3x equals 3 root 5. And now it's a good idea to divide both sides by 3. So the step that you would normally do first to get x on its own, it's easier to do it now. Well, in my opinion, it's easier to do it now. Divide both sides by 3, you get 1 root 5. X is just 1 root 5 in that case. You can write the 1 if you like, but we don't normally do that. Okay, so we're still doing the same steps you would normally do for solving an equation. Really, there was only one step there for solving the equation. That was dividing both sides by 3, except it was helpful to simplify the surd first. Okay, I can show you an alternative method. So the same question done another way. You could do the divide by 3 first if you really wanted to. So root 45 divided by 3. And now I could tidy it up afterwards. One way of tidying this up, the root 45 is the same as before. We could call it root 9 times root 5. But actually, I'll do a different trick. I'm doing it another way anyway. I may as well show you another way. I could actually say, leaving the root 45 alone, that 3 I know to be the square root of 9. And they're in separate houses at the moment, but with a division they can move in together if they like. So 45 over 9, and 45 divided by 9 is 5. So there's another way. My preference in this particular question would probably be to do the simplification first before it's a fraction. You could simplify root 45 here once it is a fraction, leaving the 3 alone all the way down. But really, you pay your money, you take your choice. It's totally up to you. I will want to see what your methods are when you solve these. I will give final answers for you to check, but I will be interested in what sort of approach you took. There's always going to be more than one route through in solving these equations. Here's another one then. You could, if you wanted to, start by simplifying all the surds. It would be a perfectly valid thing to do. I'm going to show you a different set of steps. Let's start by adding 6x to both sides. That would give us 26x here over on the left, minus root 192 equals root 75. So I've added 6x to both sides. Now I'm going to add root 192 to both sides. So I get this. And sort of the point of that was to isolate the x on its own. Got everything with an x on one side, everything without an x on the other side. I feel like now is probably the right time to simplify the surds. It's just my experience. There's no reason why you couldn't have simplified the surds earlier, or maybe in a step after this. It's up to you. I think now's the right time to simplify the surds. So 26x equals, well, 75, what's that, 25 times 3? That's the square number, so I'm going to have some root 3's here. That's giving me a clue. I don't recognise 192 immediately, but it's probably 3 times something. 3 times 60, 364s. Okay, so I didn't instantly know root 192 was 64 times 3, but I sort of had a clue here that this one involved a 3. If these are going to add together sensibly, then this one probably has to involve a 3 as well. Okay, so it's a bit of guesswork using this one here. So that's root 25 times by root 3. If they move into separate houses, root 64 times by root 3. Root 25 is 5, isn't it? This is 5 root 3. That's 8. 5 root 3s at 8 root 3s. I make 13 root 3s. So 26x equals 13 root 3s. And I'll divide both sides by 26. So x equals 13 root 3 divided by 26. And that is the correct answer, but the normal fraction 13 over 26 would simplify to a half, wouldn't it? So you can simplify this one to halves as well. Divide top and bottom by 13, so I get 1 root 3 over 2. That's just by dividing top and bottom by 13. Okay? My last example then, solve x root 3 equals 48. This means x multiplied by root 3. It could just as well have been written as root 3 times x equals 48. I haven't done anything here, I'm just sort of saying that, well, that's the same thing. This one, hopefully you'd instantly recognise you've got to divide both sides by root 3. This one, you might not instantly recognise that because there's the sort of invisible times sign there, isn't there? Okay, but let's divide both sides by root 3. That gives me x equals 48 over root 3. I knew this time it was nothing to do with simplifying surds first because that was already a simplified surd. It doesn't get any simpler than root 3. You can't get lower than 3, and this wasn't a surd. So it's got to be doing the division first. This is the right answer, but it's not in its simplest form. Can you remember why? And the answer is it's got a surdy bottom. Okay, we don't like to have surdy bottoms. Whenever you have a surdy bottom, we do something called rationalising. So I think a good idea here would be to times top and bottom by root 3, which is completely fine because that is just 1. If you multiply anything by 1, it stays the same. So I'm doing the same to the top and the bottom. Multiply top and bottom by root 3. On the top, I'm going to get 48 times root 3, 48 root 3. On the bottom, root 3 times root 3. Feel free to write root 9 if you like, but I'm going to use the rule that when you times a surd by itself, it just loses the house. So root 3 times root 3 is just 3. And finally, I know that 48 divided by 3 is 16. So 48 root 3's divided by 3 is 16 root 3's. So I think a way to summarise these would be they're still solving equations in the normal way, so to undo subtraction you add, to undo times you divide, and that kind of thing. It's still solving equations in the normal way, it's just at some point, possibly near the beginning, possibly somewhere in the middle, possibly right at the very end, you'll need to do some sort of simplification with the surds. That might be rationalisation, or that might be simplifying, moving them into separate houses, that kind of thing, or it might be expressing them all in terms of the same surd, so you can add them together and make like surds, that kind of thing. Okay, best of luck with these.